Hey guys, welcome back to chemistry. Today we're going to take a look at balancing equations review. Remember yesterday we covered mole conversions where we looked at the Y diagram and we converted. Remember, you always convert to moles first and then you can convert to wherever you need to go. Today we're going to take a look at balancing equations. The reason why we balance equations is because the universe says we have to. Remember, the universe, the law of conservation of mass, says we can't create and we can't destroy. All we can do is rearrange. What we have on this side, the reactants right here, has to equal what's on the product side. And the arrow is what's going to separate out our reactants from our products. And remember, the arrow means yields. The arrow means yields. So we have our reactants. Remember, these guys are our ingredients. It's the chemicals we actually have now, and it's what we're going to use. It's like if you're cooking, it's your raw materials, it's your raw meat, it's your potatoes. It's all your stuff you have before you actually put it together. Products is what you create, right? Once a chemical reaction happens, from these raw materials you created these guys right here, your products. It's your finished product. It's like your cake when it's done baking. You use eggs, milk, flour, sugar, and then you bake the cake. That's exactly what chemistry is. Reactants is your ingredients. Products is what you create, and the arrow means yield. So now, to balance chemical equations and make it right with the universe so we're not creating and destroying, we have to input front coefficients. We have to input front coefficients. These coefficients represents moles. So if I put a 2 here, that means 2 moles of this guy. And that's how it works. You can't change any other numbers but these front coefficients. So remember, I gave you some rules to make it easier for you to balance. So let's go over those rules real quick. First, you want to balance from left to right. You want to start here, then work your way down with each element balancing, okay? So in this equation, we're going to balance hydrogen first, sulfur second, oxygen last, sodium, right? Now let's look at rule number 2, even and odd rule. You might end up in a situation to where you have one, like look at right here, you got 1 sodium and 2 sodiums over here. So the 1 is odd, the sodium is even, so we're going to double the odd element and start completely over. So to double this guy, you'd have to put a 2 in front of it, okay? So double the odd guy and start all over if you end up with an even-odd situation. Then we had the polyatomic rule. If you see the same polyatomic on both sides, keep the polyatomic together and balance it as if it's one thing. We'll go over that here in a second. The water hydroxide rule. If you see water on one side and hydroxide on the other, turn water into HOH, which is its proper form. Turn water into HOH and then balance it using the polyatomic rule. Now it doesn't matter. Water can be on the reactant side or water can be on the product side, just as long as you have one or the other on opposite ends from each other. So you can have hydroxide on one side and water on the other. It doesn't matter. And finally, the last rule, the combustion reaction rule. If you have a combustion reaction, you're going to balance carbon first, hydrogen second, and oxygen last. So that's the combustion rule. So let's look at our equation here that we have to balance. Let's take a look. Are there any rules I can apply? Well, right away I can see the polyatomic rule. Look, here's my separation line right here, right? So I see I have a polyatomic SO4 right here, and I have another on the other side, SO4. So I'm going to treat SO4 as its one thing instead of just being sulfur and oxygen. I'm going to treat sulfate as one guy. Now let's look. Look right here. I have hydroxide on this side and water on that side. So this is the hydroxide water rule. The hydroxide water rule tells me if I have hydroxide on one side and water on the other, I can turn H2O into HOH. So I'm going to do that now. I'm going to turn water into HOH, and now I can use the polyatomic rule, because look what we have here. I have the polyatomic hydroxide right here, and now I can use this hydroxide and keep it together. Now I can separate. I'm going to balance hydrogen and hydroxide separately because this is a hydroxide right here, not a hydrogen. Hydroxide with a hydrogen on the front. So now let's go ahead and start balancing. Okay, we're going to start from left to right. We're going to start with hydrogens first. I have 2 hydrogens here and only 1 hydrogen here, so I'm going to put a 2 in front of him. Now let's look. I have 1 sulfate. If there was more than 1 sulfate, he'd be in parentheses and you'd see another number over here, but we don't have that. So that means we have 1 sulfate and look, another 1 sulfate. So sulfate is good. Let's do sodium now. 1 sodium, 2 sodiums. So I got to put a 2 on this guy. So sodium's balanced. And now look, I got 2 hydroxides. And look, I already have 2 hydroxides. Remember, the front coefficient multiplies everybody, right? The front coefficient multiplies everybody. So I have 2 sodiums, 2 sodiums, 2 hydroxides, 2 hydroxides. So now my equation is balanced. Everywhere you don't see a number, you're going to put 1. You save that for last. Now guys, this is balancing equations. What this says here is I have 1 mole of sulfuric acid, 2 moles of sodium hydroxide, and I'm going to produce 1 mole of sodium sulfate and 2 moles of water. Y'all see what I did there? You started off with 1 mole of sulfuric acid, and you added it to 2 moles of sodium hydroxide, and you ended up making 1 mole of sodium sulfate and 2 moles of water. Guys, this is balancing equations. Use this information, rewind it, watch it again to get your definitions and how to do things, but you're going to need this to do stoichiometry later on this week. Hope this helps and have a great day.